Assalamu alaikum. In the previous lecture, we have discussed the basic concept of neutral current. In this lecture, we will discuss what are the balanced and unbalanced electrical power systems. What are the parameters that decide whether a system is balanced or unbalanced? There are two most important parameters in the electrical power system. First one is the source and the second one is the load. Normally, the magnitudes of the generated voltages in the power generation are same and the phase difference is 120 degree. So as you can see here in this figure, this is the first parameter of the power systems, that is power generation. Normally the magnitudes of the generated voltages are same and the phase difference is 120 degree. So source does not decide whether a system is balanced or unbalanced. So this parameter is basically does not decide whether the system is balanced or unbalanced. It is the load which decide whether the system is balanced or unbalanced. So the second most important parameter is the load. Load is basically decide whether the system is whether the power system is balanced or unbalanced. So first of all, we will discuss what is the balance system. So there are different parameters in the electrical power system. First one is the power generation, second one is the transmission, and the third one is the distribution power system. So there are different types of the load in the system. So there are three different types of the load. Types of loads. The first most important type of the load is industrial. The second type of the load is commercial. And the third type of the load is domestic. So these are the three most important types of the load, that is industrial, commercial, and domestic. So based on the load is basically most important parameter of the power system which decide whether the power system is balanced or unbalanced. So as we have already discussed, there are two types of the three-phase connections. The first one is the Y connection and the second one is delta connection. Here we are using, as you can see here in this figure, here we are using Y connection of the sources and the load is also connected in Y connection. So let the connected load are identical. Let's suppose there are three identical loads which are connected with the three-phase power supply. So in first point, let's suppose let the load on three-phase power system is identical. Identical mean the value of the load is same on every phase, on each phase. So let's suppose the load on the three-phase power system, which is connected in Y form, is identical or same. If a load is same, then the current on each phase will be same. Hence the phase difference between voltage and the phase difference of voltage and current is 120 degree, as you can see here in this figure. So if the load are same, then the value of the current on each phase will be same. Let's suppose there are three different number of currents. The value of the first current is 10 ampere, the value of the second phase current is 10 ampere, and the value of the third phase current is 10 ampere as well. So it means if the load are identical, then the value of the current on each phase will be same. So as you can see here in this figure, the phase difference is 120 degree between phase 1 and 2, between phase 2 and 3. In each two phases, the phase difference is 120 degree. So as we have already discussed in the previous lecture, in case of identical loads, the sum of all the currents is basically equal to 0. So in case of identical loads, sum of all the currents IA plus IB plus IC is basically is equal to 0. So this is also equal to neutral current. So this point we have already discussed in the previous lecture. In case of identical loads or same load on each phase, the sum of all the currents will be equal to 0. That is, neutral current will be equal to 0. Now, as you can see here in this figure, in every instant, the sum of the current, all currents will be equal to 0. So let's suppose, as you can see here in this figure, at this instant, let's suppose at this instant, the magnitude of the phase 1 current is, the maximum value of the phase current 1 current is 1 ampere. Let's suppose IA is basically equal to 1 ampere, and at this point. Now, as you can see here in this figure, the remaining two phases currents are minus 0.5 ampere. So the remaining two phases currents are IB is equal to minus 0.5 ampere, and IC is basically equal to minus 0.5 ampere as well. So sum of all the currents IA plus IB plus IC is equal to 0. That is, IA is basically equal to 1 ampere, IB is basically equal to minus 0.5 ampere, IC is basically equal to minus 0.5 ampere as well. So sum of all the currents will be equal to 0. It means in case of identical loads or same load, the sum of all the currents in every instant will be equal to 0. And similarly, the sum of all the voltages in every instant will be equal to 0. So sum of all the voltages VA plus VB plus VC will be equal to 0 as well. So these are the two most important parameters of the electrical power systems. That is, in case of identical loads, sum of all the currents will be equal to 0 in every instant. And in case of identical loads, the sum of all the voltages in every instant will be equal to 0 as well. So now we will discuss the definition of the balanced system based on the previous parameters. So the first most important parameter is balanced system is a system in which magnitude of the voltages are same and phase difference is 120 degree. So the second most important parameter is, in case of balanced power system, load will be identical. Load will be identical. If the load is identical, then the system will be balanced. If the load is identical, then the value of the current on each phase will be same. Current on each phase will be same in case of balanced system, and the neutral current will be equal to 0 in case of balanced system. And the last one is power loss is very low or not present. In case of balanced system, power loss will be low or not present. So these are the most important parameters to define the balanced power system. A balanced power system is a system in which magnitude of the voltages are same and phase difference is 120 degree. load will be identical, current on each phase will be same, and neutral current will be equal to 0, and power loss will be low or not present. So these are the characteristics of the balanced power system. So now we will discuss what is the unbalanced system. Unbalanced system is completely opposite to the balanced power systems. Now, as you can see here in this figure, let us increase the load on one phase. So let increase load on one phase and loads on remaining two phases and loads on remaining two phases are same. Remaining two phases are same. So when we will increase the load on one phase, then the value of the current of this phase will increase. Let the value of the current in this phase is now 20 ampere. And in this phase, the value of the current is 10 ampere, and in this phase, the value of the current is 10 ampere as well. So now, as you can see here in this figure, when the load is unbalanced, when the value of the load on each phase is not same, if the, as you can see here in this diagram, the value of the current on this phase is now 20 ampere, and the value of the current on the remaining two phases are same, that is 10 ampere, 10 ampere. So in this case, when we will increase the load on one phase, then the value of the current will increase. And this will create unbalance in the power system. So due to this, the waveform will distort, as you can see here in this figure. The peak value of the one phase is more as compared to other two phases. So due to unbalanced load, there will be distortion in the waveforms. So in this case, sum of all the currents will not be equal to 0. That is IA plus IP plus IC now will not be equal to 0. That is, neutral current now will not be equal to 0 in case of unbalanced load. And if the value of the sum of all the currents is not equal to 0, then the sum of all the voltages at every instant will not be equal to 0 as well. So this is the important point of the unbalanced system. The system can become unbalanced due to unbalanced load. Normally, the load is unbalanced. So normally the system, electrical power system is unbalanced. So normally, due to unbalanced load, the electrical power system is unbalanced. So based on these important parameters, now we will discuss the definition of the unbalanced load. So the first most important parameters of the unbalanced load is, in unbalanced power system, waveforms are disturbed in terms of magnitude and phase angle, as you can see here in this figure. The magnitude of this wave or this phase is more as compared to other two phases. So the second most important parameter is current flowing through phase is not same. So the second most important parameter is current will not be same. The third most important parameter is neutral current will not be equal to 0. If all the currents are not same, then the neutral current will not be equal to 0. and the power losses are more. So in case of unbalanced system, power losses will be more. So power losses will be more. That is, I square R losses will be more. So in case of unbalanced system, the power losses will be more, the neutral current will not be equal to zero, current will not be seen on each phase, and due to unbalanced load, the waveform will disturb in terms of magnitude and phase angle. So that's it from this lecture. If you like this video, kindly like and subscribe the channel.